Hi guys, in this video we are going to discuss the daily lead code challenge for 8th of January. The problem's name is max points on a line. It has been categorized as a hard problem. However, it's pretty simple to do. I don't know why they have categorized it as a hard problem. The only thing you require to do this problem is simple basic mathematics. So let's get started with this question. So the problem states that given an array points where point I is equal to xi, yi represents a point on the xy plane. So these are the x and y coordinates of the points. Return the maximum number of points that lie on the same straight line. So for example, in the first case we had 3 points. Now we can draw a line on this system wherein all the 3 points are falling on that line. So we'll return 3 because on a single line we were able to plot all the 3 points. What about this? So over here we were having 1 2 3 4 5 6 points in total. If we do this kind of a line, we could have got like 3 points on the same line. So a line from here to here, that would have got us 3. However, we tried to draw this line, and with this line we are having 4 points on the same line, so we'll return 4. So we have to just return the maximum number of points lying on a single line. So how can we do this? So over here, one thing to note is that the constraints are pretty lenient. So the constraint is just 300 points in total. So even an n-square solution would just require 300 into 300. That's 90,000 computations in total. That would easily get done by the OJ or the online judge. So yeah, order of n-square would be appreciated or would be easy to do over here. Or even a n-square log n or a n-square root n solution should be fine. N cube might might fail this, but yeah, n-square would do, so we are good with that. So what we can say is, so since this were the points and we can draw any kind of a line, right? Even if it's not on a point, we can still draw it, but it won't make sense. So a line would only make sense if it's at least connecting 2 points. Then only it makes sense to make a line, right? At least 2 points should be connected. Only then we want to draw a line. If it's not even connecting 2 points, we won't draw a line. So what we can say is that I'll be iterating for all the points. So points. So this is the outer loop, and in the inner loop, I'll want to iterate over the other points. So yeah, what I basically mean is let's say the outer loop has a point xi, yi. So inner loop has a point x2, y2. I hope this makes sense. And the basic mathematics we know is that the slope of a line can represent a line, and the slope of a line is given by y2 minus y1 by x2 minus x1. Simple basic elementary mathematics. I hope everyone knows this at least. So what we can say is, in these points y2 minus y2 and x2 and y2 and x1 and y1, the slope would be y2 minus y1 by x2 minus x1. That is easy if we consider the outermost point and the innermost point. So outer and inner point, so this would be the slope. What we can do is that we can use a data structure over here. Let's say I'm using a map. In order to store that in a single slope, how many points are happening or how many points are occurring. So I can say let it be a pair map of slope and an integer. So slope would also be like represented by a float, and an integer can represent the number of points on that slope. Then what I can do? Cool. So once I'm done with this, then I'll say increase my max of slope, right? Because I was able to add more points onto this slope itself. So increase my slope, and once I get out of this inner loop, I can say my result is equal to maximum of result or whatever I was getting from the slope, right? The maximum element I am having in this map. So maximum in map. That is something I can do. So what next? So there's one thing you have to watch over here. So for example, there are duplicate points, let's say. So a point can, so let's say this is point A. Point A is having coordinates 2 and 1. There could be another point that is having the same coordinates. So they would be one on top of the other. So now when we'll be calculating the slopes for point A to this slope, right? So automatically whatever point A would connect, so B would also connect the same, right? So how can we keep a track of that? So we can use a variable, let's say, called duplicates. So we'll initialize duplicates with 0, right? And whenever I'll find a duplicate, so a duplicate can easily be found by, like, we can say that x coordinate, so x1 is equal to x2 and y1 equal to y2. If that's the case, then definitely the point is duplicate, and I'll increment my duplicate variable. At the end, when I'm calculating my result answer, so I'll add duplicate to the maximum in the map. I hope this is simple to understand, and this in turn should give me the result. So yeah, that's it. One concept still remains. So the point is that we are over here storing the float values for the slopes, right? So slope is basically y2 minus y1 over x2 minus x1, right? We are storing it in a float. The problem with floats is that even two values, so let's say we are having let's say 2 and 10, and we are having 1 by 5. So technically both of them should have the same answer. I hope you understand that at least. So the answer they should be having is 0.2. But what happens is when we store floating points in our system, so the answer could vary by a bit. So it is possible that this answer becomes 0.2 to 0.0000001. This would become, let's say, 0.200000002 or anything of that sort. So it would differ by a small number. And then the problem happens is that these two would be considered as different slopes, although these two should have been the same slopes. So how can we tackle this? So we can use a simple thing known as GCD, or the greatest common divisor. What we can say is that y2 minus y1 is getting divided by x2 minus x1. So let's cut out the common factors or the common divisors. So we'll find the GCD of both of them. We'll find the GCD of let's call it dy for ease. Let's call it dx. So we'll find the GCD of dy and dx. And then what we can say is that when I'm storing the values of the slope, so I don't want to store the entire slope. What I want to do is I'll just store y2 minus y1 divided by g and x2 minus x1 divided by g. So that would make sense, right? Because we are actually storing the individual values, so these are not in terms of floating point numbers. They are actually in terms of decimals itself. They are actually in terms of integers itself. So these are integers, so that's fine. On top of that, we are actually dividing it by g. So even g is a divisor of them. So it won't make them a floating point number. They would still be a integer value. So yeah, that's it about it. Now with that knowledge, we can start coding it up. While coding, I'll try to explain more about it. If you have any doubts, I hope while coding it up they become clear as well. So initially we are having points. So the base case is if points size is just 1. So yeah, we are simply return 1. I hope that makes sense. Then we'll start iterating over points. So let me call the outer point as point 1, or the point in the outer loop as point 1, the point in the inner loop as point 2. So point 2. So what I can say is, also let me create a data structure for me where I can store the slopes. So I wanted to store the slope in terms of in terms of pairs. So yeah, that's pair of int and int. So that would give me the number of points that are on this particular slope. So let's call it slopes itself, makes more sense. At the end of the algorithm, I want to return the number of points that were present. So let's call it res. I'll be returning res after all of the computations. Also there could be some duplicates as we discussed, though, so we are going to write duplicates over here. So initially the duplicates is set to 0. In the algorithm, what we'll do is that when we are traversing over it, so we can say dx is equal to 0.20 minus 0.10, and dy, that is the difference in the y axis, y coordinates, is 0.21 minus 0.11, and the g, that is the common divisor, is okay. So for the common divisor, we when we are checking the GCD, so we need to take the absolute values. It shouldn't be given with the negative values. So yeah, that's like this. And then we can say if dx was 0 and dy was 0. So if dx is 0, that means x1 is equal to x2. If dy is 0, that means y1 equal to y2. If both of them 0, that means it's a duplicate point. So I'll increment duplicate. Else if it's not that case, then what I can say is that make a slope, right? And onto that slope, add these values. So that is like dx and dy. So dx divided by g and dy divided by g and dx divided by g, and increment it up. I hope this makes sense. This was easy. So let's say already a similar slope was present earlier, then the count would be incremented. If the same slope was not present in this map, then it would make a new slope of this value and give it a value 1. Cool. So once we are done with this, then I'll come out and I'll say, okay, get me all the slopes in slopes, or this would actually now represent the number of points. So let's call it p, right? And it's a pair, so it should have two values actually. So let's call it, the first is the slope itself, the other are the number of points. So let's call it p. My result would be maximum of res comma duplicates plus p. So my result in totality could be either whatever I am having as of now, or the number of duplicate points, because the duplicate points actually fall on the same place. So we'll have to like add them up, because no matter what kind of a line we are drawing, they would always be counted, plus p. So the line I was drawing, whatever points were available on that particular line, at the end I can return res. So one thing more that you should know over here is that when I'm using this particular algorithm, initially I'm using my duplicates as 0, but wait, would that same point won't be considered, because let's say when I'm calculating a slope between 2 points a and b, right? So I'm only saying that increment the slope by 1. So I'm saying that the value of this slope is 1, but actually the number of points on this slope is 2. Then how are we calculating that? So the way we are calculating that is that when we are using this int duplicate is equal to 0, so the outer loop and the inner loop would actually run for the same element. So let's say the outer loop contains the element, so the element and index I. So the inner loop would also at least run once for the, or would run exactly once for the element at index I. So at that time dx would be 0, dy would be 0, and we would be incrementing our duplicate. So our duplicate is going to get incremented when the outer and the inner loop is running for the same element. So yeah, that edge case is also covered. Now let's try to run it up. Okay, that's an error. I'm getting that. Okay, so I've taken duplicates over here. Let's do it. Duplicate the error. So it's saying that okay, you have taken slopes over here and you're taking slope. So let's call it slopes. Yeah, this works. Let's try submitting it up. Yeah, this submits. So yeah, this was the solution for this video. I hope the problem looked easy to you, although it had a hard tag with it. If still you have any doubts, let me know. I'll be more than willing to help you out. Thanks a lot, guys.